My dear students, good morning all of you. Yesterday we started the lesson kinematics. There we discussed about the rest, motion, distance and displacement. I hope everyone is able to understand the concepts behind this topic. Now we are going to discuss about the speed and velocity, types of speed and types of velocity also. So first of all, we should have an idea what is meant by speed. What is speed? Speed means the distance traveled by a body in unit time is called as speed. So, speed means the distance traveled by a body in unit time is called speed. This is the first thing. Speed means the distance traveled by a body in unit time is called speed. And generally it is denoted by small s and is a scalar quantity. So, now how can you write this? Speed can be written as, that is speed s is equals to distance d by time t. This is the formula for the speed. And if that is the case, what is the units? The units for this in CGS, it is in centimeters per second, and in SI system, meters per second. Here, speed is always positive or 0. This is the first term that we have learned. Speed means the distance traveled by a body in unit time is called as the speed, and it is denoted by s and is a scalar quantity. Speed is always defined as the distance by time. Here the units in CGS centimeters per second and in SI system meters per second, and this speed is always be positive or 0 depending on the distance. Then come to the other one. What are the different types of speeds? Next one is types of speed. Regarding this, the types of speeds, first one is uniform or constant speed. So the first one becomes the uniform or constant speed. What is meant by this uniform or constant speed? That is, if a body covers equal distances in equal intervals of time, however small these intervals may be, then the body is said to move with uniform speed. So first we will write the definition here. That is, if a body covers equal distances in equal intervals of time. If a body covers equal distances in equal intervals of time, however small these intervals may be, then the body is said to move with uniform speed. So, the definition for the uniform or constant speed means if a body covers equal distances in equal intervals of time, however small these intervals may be, then the body is said to move with uniform speed or constant speed. Then can you give an example for this uniform speed? Yes. That is, you can write the examples as rotation of Earth, similarly moving hands of a watch, or a moving gramophone record, or rotation of fan. These are all comes under uniform speed. From all the examples, we can conclude that an object in uniform circular motion can possess uniform speed. That means here, whenever you're given, it covers equal distance. For example, at 0.01 seconds, it covers a distance of, let us say, 0.2 meters. And in 0.02 seconds, it covers a distance of 0.4 meters. Suppose in 0.03 seconds, it covers a distance 0.6 meters. For example, if you consider, what is the time difference here? 0.01 seconds. During that time, it covers 0.2 meters. Again, if you consider the difference between these two, it is 0.01. Here also 0. That means if you observe this, it covers equal distances in equal intervals of time. That's why the body is said to move with uniform speed. But physical examples, when you are given, any object in uniform circular motion can possess uniform speed. This is about the first one. Now, second one is non-uniform or variable speed. This second one, non-uniform or variable speed. It is simple. Non-uniform means here, if a body covers equal distances in unequal intervals of time or unequal distances in equal intervals of time, however small these intervals may be, then the body is said to move with non-uniform velocity, speed. That means you can always write that here, if a body covers equal distances in unequal intervals of time, if a body covers equal distances in unequal intervals of time and vice versa, and vice versa. However, small these intervals may be, then the body is set to move with non-uniform speed. So this is the second one. Here, if a body covers equal distances in unequal intervals of time, and vice versa. Vice versa means if the unequal distances in equal intervals of time, or if both are unequal. However small these intervals may, then the body is set to move with non-uniform speed. So can you give an example for this non-uniform speed? Generally, any moving vehicle possesses non-uniform or variable speed. This is not simple definition. So if it is uniform means the distances and time intervals must be the same. Here non-uniform means either distance is different or time intervals are different, like that. This is if a body covers equal distances in unequal intervals of time and vice versa, then however small these intervals may be, then the body is set to move with non-uniform speed. It's very simple. And now come to the other one, that is third one is instantaneous. What is meant by this instantaneous speed? That means the speed possessed by a body at any instant of time or at any point in its path is called as instantaneous speed. That is, if the speed possessed by a body at any instant of time, the speed possessed by a body at any instant of time or at any point in its path is called so the speed possessed by a body at any instant of time or at any point in its path is called as instantaneous speed. Generally, here we have applied limit delta t tends to 0, delta x by delta t is equals to dx by dt. This is the representation of the instantaneous speed. Generally, when you observe then for all our motor vehicles, you are provided with a speedometer. That speedometer can always measure the instantaneous speed. That we should know. That's why it's called speedometer. So, the point here you should know that a speedometer can measure instantaneous speed of vehicle. So, a speedometer can measure the instantaneous speed of a vehicle. At any instant, what is the speed that we can easily measure using this speedometer? That is instantaneous speed. Then now, come to the other one, that is average speed. What do you mean by this average speed? Average speed means it is simply nothing but the total distance traveled by a body to the total time of journey. So, average speed means the ratio of the total distance traveled, the ratio of the total distance traveled by a body to the total time of journey. Total time of journey. So, average speed, that means the ratio of the total distance traveled by a body to the total time of journey is called average speed. And generally, the average speed is given by, it is the total distance to the total time of journey. This is the formula for that. So, these are the different types of speed we have. Uniform speed, non-uniform speed, instantaneous speed, and the average speed. These are the 4 types of speeds we have. Basing on this, you may be asked different types of skill questions based on a simple term like speed, how and what they are. So, here, now we got the idea of all the types of speed. You may be given a concept like this. That is concept 1. Let us assume a body travels a distance d1 with a speed v1. A body travels a distance d1 with a speed v1 and then travels a distance d2 with a speed v2. A body travels a distance d1 with a speed v1 and then travels a distance d2 with a speed v2. Then find the average speed. Suppose this is a question that what I am given. This is a skill question, what we can say. Yeah? But a general solution we are getting. For any given numerical values of D1, V1, D2, V2, we can directly calculate the average speed by knowing this general formula. So here, a body travels at distance D1 with the speed V1 and then travel at distance D2 with the speed V2 means, let us say, suppose it travels from A to B and then from B to C, let us assume. Suppose this covers a distance D1 with the speed V1. This covers a distance D2 with the speed V2. Then, what you are going to get, let T1 and T2 be the time of travel in both the cases. Now, first of all, what is the formula for total distance? Total distance is nothing but D is equals to D1 plus D2. But what is the total time? Total time T is equals to T1 plus T2. But here we know only D and V. Distance and speed are known, but the time is not known. So can we convert this time in terms of known quantities? Yes. We know that time is equal to distance by speed. Using this concept, what you can write? It is D1 by V1 plus D2 by V2. Once you got the idea of this, then this is always taken as LCM as V1, V2. This is D1, V2 plus D2, V1 is the total time. Therefore, average speed, yes, average is equal to, by definition, it is total distance by total time. Therefore, what is the total distance? D1 plus D2 by total time. Therefore, D1 plus D2 by D1 V2 plus D2 V1 by V1 V2. Therefore, as average is given by D1 plus D2 into V1 V2 by D1 V2 plus D2 V1. This is the formula for average speed. Got the point here? So, first of all, the distance and speeds are known. While traveling from A to B, it covers a distance D1 with the speed V1, we are assuming. While traveling from B to C, it travels a distance D2 with the speed V2. To travel from A to B, the time taken is, let us say, T1. And for this, the time taken is, say, T2. Therefore, total distance is given like this, D1 plus D2, total time. But time should be written in terms of known quantities. So, distance by speed is nothing but time. By writing this, you are going. So, average speed is given by D1 plus D2 into V1 V2 by D1 V2 plus D2 V1. But for this here also, we have another thing. Suppose, here the key point in this is, if D1 is equals to D2 is equals to D, then that S average is always given by 2D1, because D1 plus D2, 2D1, V1 V2 by D1 into V1 plus V2. Here it is D1, D1 taken out as common. These two gets cancelled. Therefore, S average is given by 2V1 V2 by V1 plus V2. This is how we have to calculate the average speed. This is always we say harmonic mean. This is one concept related with average speed when distances and speeds are known. Basing on this, suppose once you have the formula, it's very easy for us to solve any problem related to this. Suppose a problem is given based on this problem. It will be given like this. A body covers first half of the distance with a speed 60 kmph, and the remaining a body covers first half of the distance with speed 60 kmph, and the remaining half of the distance with a speed 40 kmph, and with a speed 40 kmph. Then find average speed. Suppose you are asked like this. Now, what is the point that you observed? First half of the distance, second half. That means the distances are equal. When the distances are equal, here V1 is 60 kmph, V2 is 40 kmph. Then S average, when distance are equal, it is 2 V1 V2 by V1 plus V. Directly we can write when distances are equal. Therefore, here 2 into 60 into 40 by 60 plus 40, 100. These two gets cancelled, 48. Therefore, S average is given by 48 kmph. This is the advantage of knowing the basic concept. Generally, in IITs, all the numericals, when you are given, first try to get a general solution in terms of alphabets. Once you got it, then we can substitute the numerical values so that the complexity in the calculation part can get minimized. So this is the advantage. So once you know the formula, the distances traveled are equal and speeds are different, the average speed is given by 2 V1 V2 by V1 plus V2. This is one concept related to the average speed. Next one is another concept, let us say. You may be given a question like this. A body travels with a speed V1 for a time T1. A body travels with a speed V1 for a time T1 and then travels with a speed V2 for a time T2. With a speed V2 for a time T2. Find the average speed. This is the second question. This time what you are given? Speed and time is specified. If that is the case, how to calculate the average speed? A body travels with a speed V1 for a time T1 and then travel with a speed V2 for a time T2. Find the average speed. So for this, what you have to do, let us consider, again this is A, B and C. It travels for a speed, with a speed wheel for a time t1, this part travels here. But here we don't know the distances, let us say d1 and therefore here first of all, what is the total distance? Total distance traveled is given by d is equals to d1 plus d2. But here, you know, speed and time, not the distance. So can we write the speed and the time in the distance in terms of speed and time, that is given by v1 t1 plus v2 t2, because distance is nothing but speed into time from the base formula. And here total time t is equals to t1 plus t2. Once you got these two, now we can easily write what is the average speed. Average speed as average is equal to, again, total distance by total time. Therefore, as average is given by total distance d1 plus d2 by t1 plus t2. But further, it can be written as v1 t1 plus v2 t2 by t1 plus t2. This is the average speed when times and speed are specified. And if that is the case, here also the point that we can write, suppose if t1 is equals to t2 is equals to t, then what happens? Yes, average can be written as v1 plus v2 into t1 by 2t1, or this gets cancelled, v1 plus v2 by 2. Therefore, as average is given by v1 plus v2 by 2. This is in arithmetic mean. So, when times are equal, the average speed is in arithmetic mean, v1 plus v2 by 2. If the distances are equal, then the average speed is in harmonic mean. This is about another point related to this. And after that, then come to the other one, that is you may be given another concept, that is a body travels first 1/3 of the distance with a speed v1, comma, second 1/3 of the distance with a speed v2, and the remaining 1/3 of the distance with a speed v3. Find average speed. This is another concept related to this average speed only. What you are given is a body travels First one third of the distance with the speed v1, second one third of the distance with the speed v2, and the remaining one third of the distance with the speed v3. Then find the average speed. Same. First of all, what to do here? These are the points we can consider all the time. The distance. Suppose this A, B, C, and D. You can assume like that. Here, first one third means D1 is D by 3. D2 is D by 3, D3 is D by 3. Therefore, this is speed V1, V2 and V3. Times are known, T1 let us say, T2 and T3. First what you have to assume is let small d is the total distance traveled. Then what is, if total distance is d, first one that means d by 3, d by 3, d by 3. Then what is the total time of journey? Is it clear to this point? Then total time t is equals to t1 plus t2 plus t3. But this can be written as d1 by v1 plus d2 by v2 plus d3 by v3. Or d by 3v1 plus d by 3v2 plus d by 3v3. Or d by 3 into 1 by v1 plus 1 by v2 plus 1 by v3. Or d by 3 into v1, v2, v3 is the LCM. v2, v3 plus v1, v3 plus v1, v2 is the. Therefore, here, this is the, then, therefore, average speed. Average speed is given by as average is equals to 3v1, v2, v3 by v1, v2 plus v2, v3 plus v1, v3. Therefore, this is the formula because here this is known, or if you want S average is equal to total distance by total time d by 3 into v2, v3 plus v1, v3 plus v1, v2 by v1, v2, v3. This is what we are going to get. This d and d gets cancelled, so that is going up. Then the average speed is given by 3 v1, v2, v3 by v1, v2 plus v2, v3 plus v1, v3. This is another important concept. And here, once it is clear that then what we are going to get in this case is the next one. You may be given a problem based on that, a problem. A body travels first one third of distance with a speed 10 kmph, comma, second one third of distance with a speed 20 kmph, and remaining one third of distance with a speed 60 kmph. Find average speed. This is what you are given. A body travels first one third of the distance with a speed 10 kmph, second one 20, and third one is 60. So first of all, you can take V1 is 10 kmph, V2 is 20 kmph, and V3 is 60 kmph. But already we got the general formula, that is when the distance are 1/3 each, then it is 3 V1 V2 V3 by V1 V2 plus V2 V3 plus V1 V3. Then it is given by 3 into 10 into 20 into 60 by 10 into 20 plus 20 into 60 plus 10 into 60. Therefore, as average is given by 36,000 by 200 plus 1200 plus 600. This is 36,000 by 2000. 18 times, so 18. Therefore, as average is given by 18 kmph. This is how we got it. So, by learning a simple definition like speed and types of speed, we got it that different types of skill questions that may come from this simple term like speed and average speed. Now, come to the other one. Now the second one is velocity. What is meant by velocity? Velocity means, what is velocity? The rate of change of displacement of a body is called velocity, or simply the displacement of a body in unit time. So velocity means the rate of change of displacement of a body is called velocity. The rate of change of displacement of a body is called velocity. It is denoted by V and is a vector quantity. It is denoted by V and is a vector quantity. So we can write that velocity V is equals to displacement by time in a simple manner. It is displacement by time. For this also the units are same in CGS. It is in centimeters per second, and in SI system meters per second, and velocity may be positive, negative or zero, depending on the displacement. Because distance is related with speed, displacement is related with velocity. That means here, the rate of change of displacement of a body is called velocity. It is denoted by V and is a vector quantity, whereas speed is a scalar. And here velocity V is equal to displacement by time. Units in CGS this and in SI system. It may be positive, negative or zero. Got the point here? And once you got the idea of this velocity, then what are the types of velocity? Now, come to the other one, that is types of velocity. In that, again, the first one is uniform or constant velocity. Generally, now the term speed replaces velocity. So, uniform velocity means if a body possesses equal displacements in equal intervals of time, however small these intervals may be, then the body is said to move with uniform velocity. So, that is, if a body covers or possesses equal displacements in equal intervals of time, however small these intervals may be, then the body is said to move with uniform velocity. It's very simple now. Got it? So, if a body covers equal displacements in equal intervals of time, however small these intervals may be. Suppose in the place of displacement, if you write distance, then it becomes speed. So, very simple. Uniform or constant velocity. Is it clear? And the next one is non-uniform or variable speed. Non-uniform or variable velocity. What I meant by this non-uniform or variable velocity? Same. That is, if a body covers equal displacements in unequal intervals of time or unequal displacements in equal intervals of time, then the body is said to move with non-uniform or variable velocity. That is, what you can write is, if a body covers equal displacements in unequal intervals of time and vice versa. The body covers equal displacements in unequal intervals of time and vice versa. However, small these intervals may be, then the body is said to move with non-uniform velocity. Got the point here? If a body covers equal displacements in unequal intervals of time and vice versa, however small these intervals may be, then the body is said to move with non-uniform or variable velocity. But how can you say a body is said to move with the non-uniform velocity? Here, to identify that, there is a key point we should know. That is, the key point here is That note point, the key point what you can say is, if the magnitude of velocity changes or direction of velocity changes or both magnitude and direction of velocity changes, then the body is set to move with non-uniform velocity. This is very, very important point to distinguish. If the magnitude of velocity changes, or direction of velocity changes, or both magnitude and direction of velocity changes, then only the body is set to move with non-uniform velocity. And once you got the idea of this, so can you give any examples related to the non-uniform velocity? So let us say the first example, a freely falling body. Suppose if you consider a freely falling body, suppose it starts at point A. As it falls, let us say at different points in its path like that. As you move from different paths, suppose the velocity is here VA, here is VB, here is VC, here is VD. Then VA, generally if it is starting from this, or VA is some velocity in its path, you can assume. Then VA is less than VB, less than VC, less than V. You know that as the body comes close to the surface of the earth, velocity goes on increasing. Therefore, velocity at A is less than that of B, less than that of C. That means here, but every point the direction of velocity is same. Here, which is changed? Magnitude of velocity changes. Magnitude of velocity changes. Second example, a body in uniform circular motion. Suppose whenever a body is in uniform circular motion, velocity at any point can be obtained along the tangent drawn at that point. Here this is B, this is VB. Here the point C, VC. Here the point, suppose this is moving in anti-clockwise direction, if you are assuming, the velocity at D is VB. So here, direction is, at point here direction is upwards here, it is like this, but VA and VB, VC and VD all are equals to the same. So magnitude of velocity is same, but direction of velocity continuously changes or not. Therefore here, direction of velocity changes. So, a particle in uniform circular motion possesses non-uniform velocity. Freely falling body or a body proceeds vertically. In both the case, the magnitude of velocity changes, but direction of velocity remains same. So it is also moving with the non-uniform velocity. And also another example in which both will change. Suppose third one is a body moving in a vertical circle or in a non-uniform. If it is moving in a vertical circle, then the velocity at this point, let us say V1. In general, we had some value like this, root of 5 g. At this point B, the velocity is say Vb is equals to root of 3gr. If you come across the point C, velocity is obtained as root over gr. So, if you observe this, both magnitude and direction of velocity changes. So here, both magnitude and direction of velocity changes, hence it moves with the non-uniform or variable velocity. Got the point here? So, these are some examples related with the non-uniform velocity. Thereafter, come to the other one, that is instantaneous. What I meant by this instantaneous velocity? Same. The velocity passed by a body by at any instant of time. The velocity possessed by a body at any instant of time is called instantaneous velocity. This also represented limit delta t tends to 0, delta s by delta t is equals to ds by dt. This is the representation of the instantaneous velocity. The velocity passed by a body at any instant of time is called as instantaneous velocity. Thereafter, we have another definition, simple. Average velocity. Average velocity means it is nothing but the ratio of total or the net displacement of net displacement to the total time. Net displacement to the time interval. Is called average velocity or net displacement to the net time interval. That is given by V average can be written as, that is always given by S2 minus S1 by T2 minus T1. That means if you are assuming let S1 and S2 be the displacement of a body at times T1 and T2, then it is nothing but the net displacement by the time interval during the displacement is nothing but the average velocity. So these are the different points related to this one. And here also you may be asked some conceptual questions. You may be given Understanding questions. In that, you may be asked that and the first one is a body travels from A to B with a speed 60 with a velocity, otherwise with a velocity 60 kmph, and then travels from B to A with a velocity 40 kmph. Find average velocity. Suppose you are asked like this, what is the answer? Answer is very simple, it is 0. V average is 0. Why? Because it travels from A to B first along this path. V1 is 60 kmph. Again it comes back to the same point. So the initial point is A and the final point is also A, so net displacement is 0. Hence, since the displacement is 0, air velocity should be 0. Therefore, since net displacement is 0. So as long as there is a net displacement, then only we can have the average velocity. This is one you will be given. So the second question. Second one is, can a body have uniform speed with variable velocity? Can a body have uniform speed with variable velocity? Yes, the answer is yes. Where? Here, whenever the body is in uniform circular motion, at every point the magnetic velocity is same, but directional velocity changes from point to point. So, example, when a body is in uniform circular motion, then it possesses uniform speed with a variable velocity. This is an important thing. So generally, if you can come across this, at every point the magnitude is same, but directional velocity is different. Here also V at this point, like that. So, at every point the magnitude of velocity is same, but directional velocity is different, so the body moves with uniform speed with a variable velocity. You may be asked another question. That is, can a body have that is, what is the condition what is the condition for a body having to have average velocity and instantaneous velocity are equal? What is the condition for a body to have average velocity and instantaneous velocity are equal? Yes, the answer is same. Whenever the body moves with uniform velocity, at that instant, the average velocity and instantaneous velocities are equal. So, answer is yes. When the body moves with uniform velocity, then only the average velocity and instantaneous velocity are same. Okay, so these are some understanding type questions and skill questions based on the simple terms like speed, types of speed, velocity, and types of velocity. Understand? So this is about the speed and velocity. So tomorrow we'll discuss acceleration, types of acceleration, and uniformly accelerated motion. We'll discuss in the next class. Thank you. Stay home and stay safe. Thank you.